Okay, now that we've covered some basic factoring techniques, let's use them to solve quadratic equations. So the first thing that I must say is that if you're going to do this to solve a quadratic equation, one side of the equation must be equal to 0. I'll explain why in a moment. So let's say that we have this first one, 0 is equal to 2x squared minus 3x plus 1, and I want to solve it. So you'll notice that this side is 0. That's going to be important for the logic I'll explain in a moment. And the other side, you can check that it can be factored. So in this case, I'm going to say 2x squared could come from 2x and x. 1 could come from 1 and 1, or maybe negative 1, negative 1. If you experiment with it, you'll see that this is the correct factoring, a factorization of 2x minus 1 times x minus 1. Now what happens? So this is something called the zero product property, which is if the product of two things is 0, then at least one of those things must be 0. If you think about that logically, okay, what if the other side isn't 0 and you try to solve when those things are 0? Well, 0 times anything is 0, so that wouldn't work. Okay. Also, if both things are not 0, then you can't multiply them together to get a 0, so that wouldn't work. So therefore, since this side is 0, we know that either this one could be 0 or maybe this one could be 0. Let's write down both possibilities. 2x minus 1 could be equal to 0, or x minus 1 is equal to 0. Now we're going to solve for x in each case. So in the first one, you're going to get 2x is equal to 1, or x is equal to positive 1/2. In the other case, you're going to get x equals 1. So you're going to get two different solutions for your quadratic equation, x equals 1/2 or 1. Okay, let's look at a more complex one now. So we have this funny looking thing, 3x minus 7 times 2x minus 9 is equal to 8x minus 5 times 2x minus 9. So the all-purpose method is to make sure everything's expanded, put it all on one side, factor it, and then go from there just like we did. You'll see, I'll show you the smarter method in this case after I do that. So let's expand both sides. 3x times 2x is 6x squared. 3x times negative 9 is negative 27x. Negative 7 times 2x is negative 14x. And negative 7 times negative 9 is positive 63. The other side, we have 8x times 2x, which is 16x squared. We have 8x times negative 9, which is negative 72x. We have negative 5 times 2x, which is negative 10x. And we have positive 45 from negative 9 and negative 9. Now that we have this, we're going to put everything on one side. So we're going to subtract 6x squared. Actually, no, let's write it like this. Okay, so we're going to subtract 6x squared. We're going to add 27x. We're going to add 14x. We're going to subtract 63. that should give you 10x minus 41x minus 18. So now that one side is 0, you got to check that one side is 0, otherwise it doesn't work. We can solve by factoring. So you can try it out and see. Probably this comes from it might come from 45 and a 4. So this is going to be 5x and 2x, and then 2 and 9. Okay, you can check that this 2 times 2x plus 5x times negative 9, that really is negative 41x, so that's correct. And then finally, you're going to say either 5x plus 2 is equal to 0, or 2x minus 9 is equal to 0. You solve for x in each case, and you're going to get x is equal to negative 2/5, or x is going to be equal to 9 over 2. Two different answers. Okay, so this kind of works whenever you have something that's kind of messy. If you expand it and just move everything to one side and factor, theoretically it should work. Now I'm going to erase this and show you a different method that takes advantage of this common factor that we have, 2x minus 9. So first, let's again put everything on one side. So I'm going to subtract the left side expression from both sides. Now, you'll notice that you have this binomial common factor, 2x minus 9. So what's left over? Well, we have an 8x minus 5 from the first one, minus a 3x minus 7 from the second one. And it's already factored now. So you just need to simplify this factor a little bit. So if we distribute the negative, we're going to get negative 3x plus 7. And we're going to, when we simplify this, we're going to get 5x plus 2. You'll notice that this was the same factorization as before, except we did it in far fewer steps. So when you do have that common factor, you can take advantage of that. Lastly, same as before, we're going to say either 2x minus 9 is equal to 0, or 5x plus 2 is equal to 0. You end up with the same solutions, 9 over 2 and negative 2 over 5.